This is the solution video for section 6.3, problem number 10. All right, the acceleration of an object at time t is given by a equals 1 plus t to the negative third. When t is equal to 0, v is 4, and s is 6. Find the velocity and position of the object when t equals 2. All right, so first step. All right, we're given a, but we recognize that a is really the derivative of velocity. So dv dt, right? So dv dt is 1 plus t to the negative third. All right, so if I want to solve this differential equation, right, or if I want to find the velocity and position, I'm going to have to separate the variables. So I separate the variables by multiplying by dt. So I have dv equals 1 plus t to the negative third dt. All right, once I've separated the variables, I can integrate. All right, so on the left side, what is the integral of dv? Well, that's just v. All right, and then of course plus c, but I'm going to add that in on the right. All right, now on the right side, I have the integral of 1 plus t to the negative third. Now technically, we would need a u substitution. So u equals 1 plus t. So du equals, well, the derivative of that is just 1 dt. So du is just dt. So I have the integral of u to the negative third, and du is dt, du. All right, so v is equal to, all right, what is the integral of u to the negative third? That would be u to the negative second over negative 2 plus c, but then we need to replace the 1 plus t. So v is 1 plus t to the negative second over negative 2 plus c. So now, okay, I have the general solution for v, but we want the specific solution. So I want to use the fact that when t is 0, v is 4. So 4 equals 1 plus 0 to the negative second over negative 2 plus c. All right, and so I get 4 equals 1 to the negative second. That's just 1. So this is negative 1 half plus c. And so if I add 1 half, so I get that c is equal to 4 plus a half. So that'd be 4.5 or 9 halves. So c is 9 halves. All right, so what does that mean? That means that v is equal to, and I've got this, I'm going to put that negative 1 half in front. So instead of dividing by negative 2, 1 plus t to the negative second, and then plus 9 halves. All right, so that is v. But remember, v is really just the derivative of position. So ds dt, right? So now, if I have ds dt equals this, I'm going to multiply by dt to separate the variables. So I get that ds is equal to the quantity negative 1 half, 1 plus t to the negative second plus 9 halves, all times dt. All right, so now once I've separated the variables, I'm going to integrate. All right, so I integrate both sides. All right, on the left side, the integral of ds is s equals. Now remember, I would add c, but I'm going to add that in on the right side. So now I have the negative 1 half times this integral. Now remember, I'm going to use the same u substitution. So I would have the integral of u to the negative second du, right? But then I have the integral of just 9 halves dt. So it's important to remember we're using u for the first part, but not that u for the second part. All right, so then s is equal to negative 1 half. Integral of u to the negative second would be u to the negative first over negative 1 plus c, but I'm going to add it in at the end, and then plus the integral of 9 halves dt would be 9 halves t plus c. Now, I'm using a different c, so we should go back over here and we should call this c sub 1, right, so that there's no confusion, and then I'm going to call this c sub 2 now. All right, so now, all right, I want to replace the u. So I have s equals, now I have a negative and a negative, so this is really just 1 half u, which is 1 plus t to the negative first plus 9 halves t plus c sub 2. All right, so now I want to use the fact that when t is 0, s is 6. So 6 is 1 half 1 plus 0 to the negative 1 plus 9 halves times 0 plus c sub 2. All right, so 6 equals 1 to the negative first, that's just 1. So I have 1 half plus 9 halves times 0, that's 0 plus c sub 2. So now I'm going to subtract 1 half, right? All right, and I'm going to get that c sub 2 is 5.5 or 11 halves. All right, so that means that the s equation is 1 half 1 plus t to the negative first plus 9 halves times t and then plus 11 halves, right? Now, go back up to what the question says, though. All right, the question says find the velocity and position of the object when t is 2, right? So what is that really asking us to find? Well, it's asking us to find v of 2 and s of 2, right? So let's go over here, all right? So now I want to find v of 2 and s of 2. All right, so v was this thing here. So negative 1/2, 1 plus 2 to the negative second plus 9 halves, right? We want to find that. And then s of 2 would be positive 1/2, 1 plus 2 to the negative first plus 9 halves times 2 plus 11 halves. All right. And so now I get negative 1/2 times 1 plus 2, that's 3 to the negative second. That would be 1 over 9 plus 9 halves. All right. And so now I need a common denominator. So I'm going to multiply this by 9 over 9. Right. So my common denominator is 18. So I have negative 1/18 plus 81 eighteenths. And so I get 80 eighteenths, which is divisible by 2. So I get 40 ninths. Right. So V of 2 is 40 ninths. All right, and then S of 2, so I have 1/2, 1 plus 2 to the negative first, that would be 1/3 plus 9 halves times 2. So I'm just going to write this as 18 halves. Yes, I know the 2's reduce, but now I need a common denominator of 6. So I'm going to multiply this by 3 over 3. All right, and so I'm going to end up with 1/6 plus 3 times 18 is 54 over 6. And so this gives me 55 over 6, which something seems wrong here. So I get the 55 over 6, and then I have the plus 11 halves. So I almost forgot to add that 55 over 6 plus the 11 halves. And so I need to multiply this by a 3 over 3 to get the common denominator as well. So 55 over 6 plus 33 over 6 gives me 88 over 6, which is divisible by 2. And so I get 44 thirds. All right, so that is